Bismillahirrahmanirrahim. I am Muhammad Akram and I am going to teach you the course of data structure. Today it will be our first lecture on this course. As we discussed in introductory lecture that we have 6 course learning outcomes in this course. So this lecture is based on our first course learning outcome. Our first course learning outcome, it was describe basic abstract data type, stack, queue, node list, priority queue, tree, map and dictionary. Okay, before to start data structure, we need to know what is data. What is data? A data is a collection of facts from which conclusion may be drawn. Because data is the first thing. If you have data, then you can make analysis, and after the analysis you can make the conclusion of this one. Here there is one example. Let's suppose if I say that temperature is 35 degrees C. So what does it mean? What will be the conclusion? Conclusion, it will be it is hot. It is hot. So on the base of data we can make the conclusion. Here if I give you one example, that if you get marks less than 60, so what will be the conclusion? That you are failed. But if somebody get marks that is 85, so it means that he got B plus. So this is a data. 85 is a data. So on the basis of this we make the decision that you are pass or fail. So data is very important to make any analysis, and after the analysis to make the conclusion. So we have different type of data. Here I mention 4 different type of data. First one is textual. Textual, for example, your name. For example, here I have written Muhammad. This is textual form of data. Let's suppose if I write here Najran. Najran is the name of city. This is also a textual form of data. All the textual data, we have different type of data available here, and one of that is textual form of data. The second type is numeric type of data. For example, your ID, your age, your mobile number, and etc. We have many different numeric type of data, like this 35, this is numeric type of data. Your grade, that is 85, this is numeric type of data. So we have many examples that we can give that are numeric type of data. Then we have audio. For example, your voice. This is also a data. On the base of audio, sometime we make conclusion on it. We have another form of data, that is video. For example, your voice and picture. So video, we have different videos that we have watched. So these are the 4 main type of data that we are using nowadays. So after that, if you understand what is data, then we are going to explain what is data structure. A data structure, it has 2 important things: a particular way of storing data and a way to organize data. Data structure is a way of storing and organizing data in computer. In computer, how we can store data and how we can organize data. And if our data is stored in an organized way, so it can be used efficiently and effectively. So it will be very easy to use that data. So two main things that we have seen here. What is data structure? Data structure is a way to store data and to organize data. So why we are storing this data and why we are organizing this data? Because at later we can use this data efficiently and effectively. So for the efficient and effective use of data, we need some data structure. We have different data structures that we will study in coming lectures, but to store data and to organize data, we need data structures. And whenever we have done this, it will be efficient and effective usage of data. Second point is the data structure is the logical or mathematical model of particular organization of data. Data structure is what? That this is logical or mathematical model. This is model. That is logical or mathematical model of particular organization. We have different organization. So we will see in coming lectures that what are the different organizations, how we can organize this data. Number 3, a group of data elements grouped together under one name. So we have grouped the data in one name. Okay, for example, an array of integers that you already have seen. What is array and how we can declare this array? Briefly we will discuss in coming lecture about array, but here this is a data structure. We have different other data structures that we will study. Linked list, we have graph, we have trees, and many things we have. But this in data structure we group the different element under one name. So again, what is data structure? Data structure is a way to store and to organize data. Okay, what is the simplest definition of data structure? That it is a way to store and to organize data. So next slide is the components of data structure. So classic data structure, if you see this tree, that classic data structure is divided into linear data structure and non-linear data structures. So further, linear data structures are divided into, we have arrays, we have linked list, we have stack, we have queues. So these are the four main data structures that are under linear data structures. And non-linear data structures, we have trees, we have graph, we have hash table. So the components of data structures, the main thing is we have linear data structure, we have non-linear data structures. Linear data structures are divided into arrays, linked list, stack, queues. And non-linear data structures, we have trees, we have graph, we have hash table. So what is linear data structure? The question here is, what is linear data structure? Linear data structure, the data elements are arranged in linear sequence like in an array. So in array is a linear data structure. We have a linear sequence. So in this linear data structure, data is processed one by one. We are not able to process more data at the same time. So one by one we will process first one data, then second data element, then third, fourth, and so on. But non-linear is, that is different. the data elements are not in sequence, that mean insertion and deletion are not possible in a linear manner. So we will see some advantages, some disadvantages of different data structures. So we have different operations, but here the difference between linear and non-linear data structure is that in linear data structure, data elements are arranged in linear sequence, in a sequence, but non-linear, that is not in sequence. So non-linear data structure, we have trees, we have graph, and we have hash tables. So this is again components of linear data structures. In linear data structure, what we have seen, that we have arrays, we have linked list, we have stack, we have queue, we have priority queue, and so on. Here there is a brief that array, both ordered and for ordered and unordered array, size will be fixed size. So in detail, in I think lecture number 3, we will discuss about arrays, what is array, how many type of array, and so on. So linked list, they are variable size. So this will be our separate lecture on linked list. Then we have stack, and in stack we have to add to top and remove data from top. This is the about stack. Queue, add to back and remove from front. So we will add in queue data from back side, and we will remove data from front. Priority queue, add anywhere, remove the highest priority. So we will see one by one all these data structures. All these data structures are linear data structures. Same way, we have some non-linear data structures, and the first one is that we have hash table. This is unordered list which use a hash function. So hash function, we will see in coming lectures what is hash function and how to insert and search data. Tree, a branching structure with no loops. This is a tree. So we will see what is tree and different functions of tree, different operations of tree, and many things we will discuss in coming lectures. Graph, a more general branching structure with less connection condition than for a tree. So this is a graph that will be a separate almost two lectures on graph. So this is our basic course, that we have linear data structures, we have non-linear data structures, and we will study all these data structure in coming lectures, and this is our course. After this, we have seen what is data structure, and we have discussed that data structure is a way to store and to organize data. So here the important things, the 3 points, what is the goal of data structure, as we discussed, to organize data, and what is criteria, that why we organize data, because there are 3 main advantages. To facilitate efficient, that storage of data will be efficient, retrieval of data will be efficient, and manipulation of data will be efficient. So we have 3 criteria, that if we have chosen some data structure to organize our data, and then it will facilitate us the efficient storage of data, efficient retrieval of data, and efficient manipulation of data. So then we have design issue. Select and design appropriate data types, because whenever you have some problem and you have to select data structure, then your data structure will be the first thing that must be accurate. If you have selected a best data structure, best data type, then your solution will be the best one. And this is the main motivation to learn and understand the data structures, because we have different data structures that we can use for the same problems, but which data structure will be the best, This is the important thing, that selection. And to select the best data structure, you need to understand all data structures, their advantages, their disadvantages, and the techniques how to use that data structures. So this is the need for data structure. Why we need data structures? So why we need? Because it facilitate efficient storage of data, efficient retrieval of data, and efficient manipulation of data. These are the three things, and it's very important. This slide is very important, that why we need data structure. Next, there is some comparison. Here it is given some comparison of different data structures. This slide is just give you some advantages and some disadvantages of different data structures. We will study in detail in coming lectures about arrays, ordered array, stack, queue, linked list, binary tree, hash table, heap, and graph. But here simply array. What are the advantages? It provides us quick insertion facility, that we can insert data very quickly. Very fast access if index is known. If you know the index, that which index you have to insert data, it's very easy to insert. But at the same time, it has some disadvantages, that slow searching is very slow. Because if I'm going to search anything, then I have to start from index 0 and I have to search all the array until I get the element that I am going to search. And deletion is also very slow, and size is also fixed. This is the some disadvantages of array. So whenever we will discuss array, we will discuss in detail advantages, disadvantages. Same way for stack, when we will discuss stack, we will discuss about advantages and disadvantages. This slide is just our view of different linear data structure and different non-linear data structure. But in coming lectures, we will discuss all this in detail. So we have seen data structures, what is data structures, and different type of data structures. Now we have data structure operations. We have some operations that are very important, and all the data structure you will find this. First one is traversing. What does it mean by traversing? That is accessing each data element exactly once, mean visiting. That you have elements in data structure and visiting one element at a time. This is called in data structure terminology traversing. Accessing each data elements exactly once so that certain item in data may be processed. So why we have to visit data elements in data structures? Maybe we want to process data, we want to do some manipulation, we want to add something, we want to subtract something. So that's why we are visiting data elements one by one. Searching, it's very clear that finding the location of data elements in the structure. We are looking to search something. We are searching, so we perform this operation, searching. Insertion, as its name shows, to adding a new data elements to the structure, to adding new thing. But in data structure, we use terminology insertion. Then we have number 4, that is deletion. So it's also very easy to delete some data elements. And then we have sorting. Sorting, we have to arrange data in some order. So order can be ascending order and can be descending order. And then merging. Merging means to combine data elements from 2 or more data structure into one. So combining, to merge 2 or 3 data structures into one data structure. So these are some basic data structure operation. The first one that we have seen, traversing, then searching, insertion, deletion, sorting and merging. So this was our today's lecture. If you have any question and if you want to say, you can ask me in next class. You have my email address. You can ask through email, and or you can visit my office if you have any question. So just we have a brief overview of today's lecture, that what we have studied in today's lecture, that what is data. And data, we have said that it is collection of facts which conclusion may be drawn. So we have different type of data: textual, numeric, audio and video. Then we have seen what is data structure. The important thing is, a data structure is a way of storing and organizing data. To store and organize data. Then we have different type of data structures, and it is divided into mainly linear data structure, non-linear data structures. And what are the linear data structure? We have array, linked list, stack and queue. What are non-linear data structure? We have tree, graph and hash table. Then we have seen why we need data structure, and we have seen that because if we have chosen data structure, then it will facilitate us the efficient storage of data, efficient retrieval of data and efficient manipulation of data. Then there are some comparison of different type of data structures that we will study in coming lectures. Data structures operations, we have 6 main operations that you will find in all data structure, that is traversing, searching, insertion, deletion, sorting and merging. So thank you very much. So if you have any question, you are welcome through email or by visiting my office in my office hours.